Hello. So we're going to be talking about parameter or list mutability and its effect in this video. So what that means, what mutability means, for those of you who don't know, it's when it's changed. So we kind of talk about this when we talk about list and strings. And we're going to go into a little more depth into this in this video along with its association with parameters. Okay, so let me present this again. All right, so let me pull up the code. So this piece of code is used for demonstration purpose. You probably should know what it does. We talk about this when we talk about a function that, okay, I define a function for that takes a parameter a and I change that parameter. I assign it to 10. Now, before I actually call the full function, I declare a global variable, a, okay? And I pass that a as a parameter to full, okay? So, and the question is, so when full is done and we try to print out a, what are we going to print out? Is it going to be 1 or is it going to be 10? And you hopefully do know that. Let me run it. Okay, it is 1, right? Why is it 1? From last time, we said that this a is a global variable, okay? And a parameter of a function is like a local variable of the function, okay? The only thing is this local variable, its value can be set by the caller. And in this case, a, the parameter is set to 1. So if we print that out, a in full is format a. Okay, so when we run that, a, the parameter in full, gets the value 1, and that comes from the global variable. Okay, however, because this is a local variable now, it just obtains the value of 1 from the global variable, but it's its own variable. This a, this parameter, is a separate a from the global a. Okay, so when we change the local variable or the parameter a, it does not affect the global variable. Okay, because they're just two different variables, despite the fact that they have the same name. Okay, I hope that makes sense. And I'm going to move on to the next one. And the next one should be even more obvious, I hope. I'm just going to put this piece of code inside another function. Okay, and I'm going to call that function right here. So this function, it declares a variable and then it calls full and passing that variable as a parameter to full. So when full returns, what is the value of a? Take a moment to think about it. You should know what it is. Okay, so again, where even though full modifies its a, the a in func remains 1, right? And the reason for that is that this a is local to full and this a is local to func. They have nothing to do with each other. So changing a in full does not change the a in func in any way. Okay, so that's why. Now the next example. So we've kind of worked with, we look at integers or numbers as a parameter. What about in this case, our parameter is not an integer, but a list. Okay, so the same pattern here, though, that we defined a function that takes a parameter, and we change that parameter to a different list, right? And before we call the function bar, we declare a global variable that is the list 1 and 2, and then we pass that list to bar. And what do you think is going to be the value of this global LST when bar returns? Okay, so let's run it. When it's all said and done, LST, the global variable, is still 1 and 2, despite the fact that, or not the fact, but what might appear to some of you that bar is changing it. Okay, and this is the same reason, for the same reason of what happened previously when the parameter is a number, that the parameter LST, oh, I guess I use a slightly different name here. Let me change that, LST. It doesn't matter what the name is, really. Let's keep it L. So this parameter is a local variable, 2 bar. This LST is a global variable. So these two are separate variables. So even though I change this LST inside bar, I'm not changing the global LST, right? So that should hopefully make sense. So here's a little question. So are we ready to declare that a function can never change its parameter and make that change visible to the caller, right? Which is what we have seen so far. But can it never make changes to its parameter such that those changes would be visible to the caller? So you can think about it, or we can move on and I'll show you an example. The next example. This. Okay, so the next example is, it looks almost the same as the last one, except what bar does is that instead of assigning a different list to its parameter, it changed one of the elements in the parameter. Okay? So instead of doing this, just change the list, just change L, change the parameter to a different list. I change one of the elements in the list. What do you think the effect is? Let's run it. Interesting, right? This global LST, it used to be 1 and 2, but after the call to bar, it got changed this time with its first element changed by the function bar. Okay, great. How does this work? So in order to understand this, we kind of have to go back a little bit to the basics of assignments, which we have been using for a while now. So it is time to understand it a little better. This is what I call actually just a preview, because it's still not quite technically the complete picture, but at least this is one step closer to the truth than what we learned previously. Okay, so let's look at this example. I'm going to comment this out. Next example, in a simple integer assignment. So this is what we do here. Okay, so we set a equal to 10, and then b equals to a, so you should expect b now holds the value 10, and then we change b to 20, a different value, right? So when I print out a, the value of a and b, You should know what it is. So pause for a moment, think about what it is, and I'm going to run it. So A is 10, B is 20, right? It makes perfect sense. Changing B does not change A. Okay? That's what it says here. Shouldn't be any surprise. Okay, next one. How about a list assignment? And that would be this one. So, okay, we're doing something very similar to the integer assignment, except we're using list now. So we have a L1, this one, which is 1 and 2. And then we create a list 2 and assign list 1 to list 2. So at this point, let's print out what L1 is and L2 is. We'll run it. And then after we print that out, we assign L2 to another list. And then we'll see what effect that has on L2 and on L1. Okay? Let's run it. All right, so after we assign L1 to L2, L1 is 1 and 2, L2 is 1 and 2. Okay? Just as expected. Now, when we assign L2 to a different list, 3 and 4, L1 stays as 1 and 2, L2 is now 3 and 4. Okay, so hopefully no surprise there. Okay, so let's move on to the next example. Okay, what about when we're getting closer to what we were doing with the parameters now? So, okay, we do the same thing. We start with L1 assigned to 1 and 2. L2 gets assigned L1. Okay, so at this point, we print it out again. They should look exactly the same. And then we change the first element of L1. I'm sorry, L2. And then let's see what L1 and L2 are after this assignment. Okay, no surprise, L1 is 1 and 2, L2 is 1 and 2. That's because of this. Now, when we change the first element of L2, L2 is 999 and 2, obviously, right? That's what we expect. Look at what L1 is. L1 is also 999 and 2. It's the same as L2, even though we appear to have only changed L2. The change in L2 get reflected in L1. Now, why is that? So what it is that it's kind of the how the assignment operator actually works. So what the assignment operator really does is that it creates an association or a reference to a value. Okay, so in this case, L2 is now associated with the value of L1. Or in other words, L2 references the same list that L1 references. So the word kind of reference, you're going to be seeing this a lot, especially when we start talking about object-oriented programming. So it can be used as both a noun and a verb. And it just kind of means, L2 is pointing to this particular list. So in this very first line, when L1 is assigned the list of 1 and 2, L1 is really a name that points to or is associated with or references the list 1 and 2. In this second line, L2 equals, L2 is assigned L1, meaning L2 references the same list that L1 references. Okay, so that's what happened. They are L1 and L2, they're really kind of pointing or reference to the same list. Which is why when we change an element in the list referenced by L2, because L1 referenced the same list, we see that change through L1 as well as L2. Okay, hopefully that makes some sense. And if not, try to go through this slide again, listen to what I said again, and or post questions in the discussion forum. Okay, so now okay, so let's go back to what happened. Then I mean, given that definition of the assignment operator, what happened to the previous case? What happened in there that such that we get the result that seems at odds with what we're getting here? Okay, so everything is the same up to this point, right? And when L2 here, L2 itself is assigned the list 3 and 4, L2 now reference the list 3 and 4. So L2 at this point reference a different list from L1. L1 still reference 1 and 2. L2 references 3 and 4. So that's why when you change L2, I mean, then you just get the new list, right? It's a completely separate list. Okay. So, all right. So now we're ready to understand what really happened in the code that perhaps surprised some of us. Oops. There. That is this piece of code. Okay. So what really happened here is that, okay, we have a global variable LST that is assigned the list 1 and 2. Okay, so global LST references the list 1 and 2. In the next line of code, we come to bar and we pass the global variable LST to as a parameter to bar. So the parameter LST of bar gets assigned LST, the global, probably should use different names, that because this is an assignment, right? So LST, the global reference this list. So LST, the parameter, also reference the same list. Okay? And that's why when we execute the next line, when we change the first element through the parameter as LST, and that changed this element in the list, that change is visible to the global LST. Because, again, both the parameter LST and the global LST are pointing to the same list. And that's why when bar is done, we come back and print out the global LST, we see the change that's made inside bar. Okay, so here's kind of a summary of what we just did. So regardless of the type of the parameter of a function, okay, whether it's int, float, bool, string, list, I think that's mostly what we learned up to this point. Okay, regardless of the type, if we assign a new value to that parameter, which kind of means it references a different value, the caller of the function will not see the new values. Okay, that's kind of what the several examples that we've shown up here. However, if the parameter is a list, and it's not just limited to the list, but this is kind of the type that will do this different thing for us right now. So if the parameter is a list, and if we change part of the list by using the square bracket or by other operations that will modify a list, such as appending things to the end of the list, deleting a list, etc., the caller does see the change because both the caller and the callee reference the same list in that case. Okay, so this is not the result of the immutability of the type, and that's a claim made by Professor Losev's writings. That is a very subtle difference, but that's the claim in the writings, and I, to the best of my knowledge, that is incorrect. Okay, so that's the first thing. And then the next thing is, hopefully this makes sense, but as we start talking about object-oriented programming very soon, at that point, we will learn new things such that we will get like a complete technical picture of how exactly this thing works. But for now, this slide, this summary here is what you need to know about how the change in a parameter affect the changes, well, how the change in the parameter affect how the caller sees the argument it passes to the function. Okay, I think that's the end